We'll just wait for Keynote to restart. I figure it's probably more programmers than sociologists in the audience. So first thing to talk about is the notion of a case study. Should we do a starting over, starting now, or just keep going from here? About the development of something, especially, let's keep going, particular in order to illustrate some general principles. First we want to convince, anyway, I don't need this for this part. So the first thing we want to convince you is that miniKanren is an interesting exercise to be a case study of. The second thing that we intend to talk about is prove some of the general features of hold on, I actually need to pay attention for this to come up. All right. And we're back. The second thing we want to talk about is what makes miniKanren a desirable host. What makes a good host for miniKanren? And finally, we want to, from that, draw more general lessons about what to do when hosting a domain-specific language, miniKanren or otherwise. So miniKanren is itself a shallowly embedded domain-specific language used for doing logic or relational programming. It was first introduced in the book The Reason Schemer by Dan and Will and Oleg some years ago, in 2005 thereabouts.
In the neighborhood.
And all the information about miniKanren, the tutorials, implementations, uses can all be found at the website minikanren.org. So a domain-specific language it's a programming language or spec that offers, through some notations and abstractions, an expressive power that's usually focused and restricted to some particular problem domain. It's kind of interesting to consider that think of three long-existing general-purpose programming languages. Think of really, really well-established programming languages. The ones that came to my mind were Fortran, COBOL, and Lisp, all of which you can kind of argue started life as domain-specific languages for formula translating, business logic, and list processing. So the lines get kind of blurred. There's a couple places our lines are going to get blurred between how specific does our domain have to be. These are obviously movable categories, and we'll also be discussing some other gradients as we go. But these aren't unlike a lot of the things we talk about in programming language. Fixed categories, yes or no, right or wrong. Some of this is going to be inevitably a judgment call. But places where there's room to give different decisions, different choices you can make, that's sort of on the artistry side rather than the science side of what we do. And that's not a bad place to be all the time. So, as an embedded domain-specific language, that means it's embedded in a host, and as a result, the language inherits some of the infrastructure, some of the framework from the host. That's the point of having an embedded domain-specific language, is that you don't have to develop the whole thing from scratch. You can sit on top of the shoulders of whatever your favorite language happens to be. Just incidentally, the term domain-specific embedded languages was first coined by Paul Hudak in 1997. So an example of some miniKanren is the relation appendo. Dan, I think this is you and Will's usual go-to, your factorial.
Yeah, this is our factorial.
The O on the end stands for, what was the?
Well, kind of like the output variable, except in logic programming, you never have an output variable.
I've also heard, I think, that the O is the top of a question mark.
That's on the names.
Okay.
So in Scheme, for example, you have predicates, and when you write a predicate, which is going to return true or false, you always have a question mark at the end. Well, we wanted to have some way of distinguishing relations from regular functions, so we stuck a little O degree symbol at the end, and then it had this strange sounding name like appendo.
Last night it was
sort of caught on as a fun thing to do, but of course it's totally irrelevant.
Last night it was, oh my goodness, there's an extra argument to my function.
That's what it was last night. Yes.
So this is, you know the append function. This is its cousin, the append relation. We're describing what it means for three things to have the append relationship. So there's two ways it can hold. One, if the first element is empty, then the second and third things are the same. Otherwise, posit the existence of two more variables and say that the first element is the composition of a head and some rest. Then, if a pin holds for the recursion, then the result of the recursion plus the head on the front is something else that inhabits the append relation. And even if you're not a miniKanren expert, don't see how what this code means. You can understand the run at the bottom. We're using a pin like you would your regular old append function. If I get the list BCD and the list EF and say what happens when I append those two together, I get back out BCDEF. miniKanren always returns a list of answers.
Right.
So there's one answer you get back out. BCD and EF yields BCDEF.
And Racket always returns the quoted list of the answers.
So the point is, you can, if you're new to miniKanren, I just want to write functions like I've been doing as a plain old functional programmer. I love it. You can do that, but by taking your append function and turning it into a relation, you get superpowers. And you don't have to just use appendo like you would append. You could fill in all or partial answers for any of those three positions, L, S, and O, and miniKanren will do its best to give you answers to establish the rest of it. That's the power of relational programming. Yes?
So you add just like a Q, right?
Correct. Q for query. Thank you. Yes, Q for query. So why miniKanren as a case? Well, it does have some practical commercial uses. It's been used for in industry for doing malware detection, for processing database queries, for web testing. And the fact that there are companies out there using miniKanren in production is cool and neat. But that's not the kind of stuff that gets Dan and Will and I all excited. Mostly it's the kind of PL awesomeness stuff that we can do with it. We've implemented, or miniKanren researchers have implemented exponentiation algorithms that double as logarithm algorithms. Dan, I think you said that the OLEG one for multiplication is really a backwards running long division.
That's correct. And it takes someone like a Ken Sean to say to you, after studying it for a month, say, oh, that's just long division, backwards. And then once you know that, it's easy. So if you're ever reading the book, remember that.
So we've got, likewise, in a similar sense that a pin works in multiple directions. You can write a type checker that works as a type inferencer or a type adder. A combinatory logic reducer that actually also performs combinator synthesis.
And we'll figure this one out.
Yeah.
Go ahead.
And language interpreters that also double as fuzzers or Quine generators.
And again, we'll figure this one out. And at the speed of light. Continue.
So there's lots of cool stuff you can do with it, and that might make miniKanren an interesting object of a case study, but there's also some intrinsic reasons that miniKanren is interesting. Not just what it can do, but what it is. We've got implementations in fewer than 100 lines of racket code. 1/4 of that's just to implement the stuff to do unification. It's a small enough artifact that you can experiment with it and small enough to be an object of study. And that's not just 100 lines from getting rid of all the line breaks. We think it's part of the other reason Dan and I like it is we think it's pretty.
Well, it's not only getting rid of line breaks, but when you write papers, you get 2 columns. We only get 1 column for the code. And that's the line count. It's
So
really quite a difference.
We've got people have done more than 50 implementations in at least 30 languages, and that means that you can do an interesting cross-section of what do we get from implementing it in this language versus this language. What does my host bring to bear? And having that cross-section also makes it an interesting thing to study. And thirdly, that notion where miniKanren programs are derived from, we actually haven't showed this to you yet, where programs in miniKanren are derived from programs in the host language. We start with a racket program and then transform that into a miniKanren program. And a result that you can superpowers. But not many domain-specific languages I can think of have this kind of development model. And that too makes it sort of interesting. So let's do some code right quick, Dan.
I think that's time.
All right, so
Is that the whole implementation?
you want me, which one's the racket? This is reverse. Okay. So here's our append relation appendo relation we looked at beforehand. We want to do
the definition of reverse right here.
Yeah, we want to do a similar thing for reverse, and that might be
Standard
kind of tough
way
to
of
see.
doing it. But if you've ever written one reverse, you've written them all, so to speak.
All right, so, all right, well then we can show this one off. Functional programmers have written reverse. This one's a slightly more sophisticated notion of reverse, but it's doing the same thing. We just happen to, and this is the model we use for writing miniKanren programs now. We translate it into a still perfectly nothing out of the ordinary functional program. It happens to look suspiciously like something that might turn into miniKanren, but so far as I know, when I run it or use it, it looks just like any other reverse program. What does it mean? The reverse of list is, if the list is equal to the empty list, then the answer is the empty list. Otherwise, we can decompose it into two pieces, reverse the back half, and then append the answer onto a list containing the first element. So, define relation. First thing we do, and the most important aspect, add the O on the end.
Must always add the end.
Con becomes con D. How do I say that two things are equal in miniKanren?
That's the unification algorithm. That one was easy. How about this one?
So, well,
A and D look like they could be fresh variables.
I need to posit the existence of two new variables. Fresh A and D. And then we'll say that so I've got So I've got A and D fresh in this one. Now we need to posit the existence of one more variable, fresh R.
Mm-hmm. Don't worry, I'll tell you if you make a mistake.
Just like Tuesday and Thursdays.
Yes.
So,
Don't forget the O in reverse.
so reverso D to R. What does it mean? When we used to say that R is the reverse of D, now we say that they inhabit this relationship. And finally, we can use our good old append relationship to finish the job off. So, let's see.
Missing
And then,
Yes,
an
sir.
O.
Oh my. Appendo.
Get rid of the.
Appendo R to the list A is the final answer. And we've got an appendo relation.
Now, for those of you who may be reading the book right now, define relation is not in there. That's under negotiation.
All right, so run 1Q, get the answer. What happens when I reverse O? Yeah. Oh, question. Hit me.
Could you just reiterate what fresh did in the
Sure.
first time?
Fresh scopes a new variable. It gives me a fresh variable. You might say the backwards E in your formal logic class. It's kind of like that, but I want to make sure I've got a brand new, never before seen, new to the universe variable to which what I can use as an answer. Like when you think about describing relationships, if I want to say Portugal is 2 countries away from France, I might posit the existence of a Spain and say that they both bear the one country away relationship to describe it. So often when describing these relations, we have to posit incidental variables, and that gives them to me. So I can run it, and the reverse of the list ABC is the list CBA. We can also do it the other way around. And this is the flexibility that logic programming gives us. And if we had more places in our relationship, we could partially or completely instantiate all of these, and we can have miniKanren generate stuff for us. So that's the power that it gets us.
Can you do palindrome for us?
Yeah, based on what we've got, pop quiz. How do I ask if something's a palindrome? How do I ask for a palindrome?
give it the same argument twice.
Yeah, give it the same argument twice. So run 1,
You're no longer
Q.
allowed to take C311.
reverso, reverso Q, Q. Give me a palindrome. All right, the empty list is a palindrome. How about give me 10 of them? All right. I could have asked for, give me elements that inhabit the append relation too, and miniKanren would spit them out for me. I could give it an answer list and say, miniKanren, give me all the ways that the first two elements can append together to give me the third, and it'll spit it out just as quick as this.
These are not actually.
Oh yeah. What are those? What is that underscore dot? What is that?
Yeah, what is that?
These
have to be the same. These have to be the same, and this one, of course, will be.
So they're arbitrary miniKanren terms where the number indicates which ones have to be the same. So if the last ones are the same, the second to last, the outside ones, the second outside one's the same, etc., then we've got something that's an honest goodness bona fide palindrome. Cool.
We have no idea what this is. We just know it's everything.
All right. So how about, which one has the O on the end of it? Which one has the O on the end of it?
Val Expo?
Val Yeah.
Oh,
Is that
Val Expo. Oh, which file?
Yes. This one, yes. All right, yeah, good. It's a little tough to see from here. All right, so Dan and I promised, and well, we could go show it off right quick if you want, or we could just run it. So the same power that we use to turn a reverse function into a reverso relation, we could take an interpreter for a programming language, the kind of thing that Dan has students write on the third week of class in his undergraduate course, and sprinkle a little miniKanren at it, and you get a relation between an input and output. So let's see, run one Q, eval expo, a program, let's see, left lambda x of cat with what yields what output. Cool. When I call the identity function on cat, I get cat back. That's good.
Remember, the friends are to be ignored. Never friends.
But how about if I ask for some Q that yields me cat as an answer? Well, okay, quote cat.
Only one answer.
If I evaluate cat, I get cat back. That's good. That's good. What if I ask for 10?
But now it gets more interesting. And you'll notice some weird things up there. Because this miniKanren is much more powerful than, say, MicroKanren.
What's that?
Well, MicroKanren will come up. And the things like this say, well, those guys better be symbols, this guy...
So we've
symbol
added some
will not be
additional
here.
constraints on top. But the 100-line little implementation that Dan and I built, we have a core relational language, it's what's smaller than miniKanren, it's MicroKanren. And we sprinkle little syntactic macros on top of that, and you get a perfectly serviceable functional logic programming language. We add some constraints, and the constraint printing framework adds a little additional complexity, but it's still perfectly understandable. And what I want to
Why
show
did you
is-
bring this up?
Oh, because if I run it, it's generating for me programs that when I run them evaluate the answer I wanted. I can generate test data for whatever programs I wanted. That's kind of neat.
Well, what can you do with it?
I don't know yet. What can I do with it?
I don't know.
I can't think of anything. It doesn't seem like it would be useful for anything. It's a parlor trick. It's a pure toy. What could I do with it?
I don't know. Throw a Q in there.
Thank you.
Yeah.
Yeah. All right. So I'm asking miniKanren, given the eval expo relationship, to give me something where the program evaluates to the same thing as the source.
Does anybody know what that is?
It's a quine.
Right. And there they are.
That was 10 of them, you'll notice.
And we're not even going to bother to prove it to you because there are so many videos on miniKanren.org that you can watch it and see it. So let's move on.
But there's interesting stuff to be done. All right, so, well.
And so closes the interactive portion of our.
Well, let's. I did want to go. I mean, I guess we could look at it if we wanted to.
It's a
What are we relying on here?
Oh.
So this is our implementation. We're relying on the ability to take functions as arguments and return functions as values. The equal we saw, it takes 2 arguments and then returns a function waiting for a third one. So higher functions, closures, we've got to have those. We, all over the place, we use cons as our primitive data structure. We take two cells, stick them together, and return another cell. Now this list and this quasi-quote comma syntax, that's just all pretty sugar to make the presentation more legible. But really, it's all cons under the hood. So higher order functions, con cells. There's, honest to goodness, one macro sitting here in the implementation.
And is it an important macro, Jason?
Yes.
How important?
Critical.
Yeah, really critical. And there it is. No, that's not it. There it is.
Yeah, so this is how the define relation, guess what it does? It helps us define relations. And I don't want to get into the details of what it's doing, but we absolutely need some way that gives the ability to define relations, do recursion. Without that, miniKanren doesn't get it.
So mention what's going on with the G, Jason. It's an expression.
Okay.
That's the important part.
Right.
And you don't want to do it now.
Yes. All right, we want to delay it, and we're introducing variables in lexical scope, so we need to make sure we don't do any unnecessary capture. That's an important thing. And we also rely heavily on the garbage collector. miniKanren, we don't do any of the sorts of things that a lot of languages would have to do for actual explicit backtracking and unsetting things. We rely on the garbage collector to do that for us as pious functional programmers. So,
but we're done with this, right?
all right, so to go through the list again. Closures, hygienic macros, S expressions, and garbage collection. You're just listing the features of scheme, guys.
Or racket.
Or racket, sure. This could be racket as
Haskell
well.
has some of that, so you can think of it also Haskell.
And so we might have closed this with, if you want to implement a miniKanren, just use racket or scheme. And that would be that wouldn't be much fun. Partly it's not even true because we can get by without a lot of those features. We don't necessarily need closures.
How's that possible?
Well, there's an old story. I'll tell you the abbreviated version. But Norman Adams wrote the paper that objects are poor man's closures. If you're using, you can use objects to just stick an apply method on there, and you can use them like close over lexical scope like you would. And that gets you through some stuff. But Christian Queniak, in his list in small pieces, points out that closures could also be seen as a poor man's objects. Closures are an impoverished version of object because you only get one method that you get to do with them. And there's some play back and forth. Point being, Anton Van Straten wrote it up as a cool little Zen koan you can find on the web. If you start off thinking the one way, objects are a poor man's closures. And then if you think about it really hard, closures are a poor man's objects, and thus Anton reaches enlightenment. So we don't need closures. If you've got an object system, that'll be good enough. Somebody's implemented a miniKanren in Java, where they, rather than using functions, they build them as a class and attach methods to it. Lots of people actually took this approach.
What do you mean lots of people?
On the website miniKanren.org, we've got listed all the implementations up there. And so if you've got whatever your favorite language is, odds are there's a miniKanren for you already out there. If not, we want to try and convince you to go build your own, give it to us, we can stick it up there. So we don't really need closures. Hygienic macros, though. We don't really need those either. Hygiene prevents captures during variable capture during macro
What
expansion.
if you don't have macros?
And it was, well, I'm not there yet.
Oh, okay.
It was originated in Scheme, but Dan, do you want to
get through that fast?
So,
Nothing much to say about it.
nothing much to say about it, just a dissertation's worth.
That's right.
But,
Really cool piece of work.
so it was invented in the 80s, which is 10 years later than all the rest of computer science. But that means they were doing macros back in the bad old, good old days of Lisp. And so Dan and I wanted to implement one in a language called Shim that doesn't have hygienic macros yet. And the way that you used to do it, I think. So the first two, they're fine. You can, if you're not doing any scope capture, you can't tell the difference. But the way you used to do it is you get a brand new, honest to goodness, never seen symbol, or string, make it a symbol. And then use that in your scope. And you're guaranteed you're not doing any scope capture if you've got a brand new name new to the universe. And so you don't really need hygienic macros. You can use a non-hygienic macro facility. Or if you don't have macros at all, you can get by explicitly adding delays in places. It's not so clean to the code, but you can get by doing the thing, dropping delays that are required for miniKanren to work. And you can read this in a couple of Dan and I's papers. You drop the delays explicitly in places, and you don't need the macros at all. So we can get by without macros. As expressions. We actually kind of do need something to work like this. What made the transformation from append to appendo, reverse to reverso possible was that we had cons, car, and putter as our language primitives, and we're using binary trees, the basic data structure in miniKanren. The fact that we could decompose everything the way miniKanren wants, and we could sort of simulate that beforehand in Racket, that's what makes the transformation go and makes us able to develop programs like this. Believe me, if you've never written a huge miniKanren program, being able to write it as a function in a language that sort of feels like home at first, make sure it works in one direction before you start running it backwards, is a huge advantage. And we had to have cons, car, and putter to make that work. If your host language doesn't have those, well, you can either change the term language. And somebody wrote an OCaml implementation where this isn't perhaps the only example, but adding lists as basic elements over which to do unification. You could change the term language to support whatever term structure you've already got, and that's an option. And adding lists is cool, but why not an array language? As far as I know, we don't have APL-Kanren yet, or J or K-Kanren. How cool would it be if you had arrays as a transparent data structure over which to do unification? How is that plum still sitting there? But if you don't have that, the other thing you can do is implement cons, etc. If they're not already in your host. And a lot of people did this. Justin, like did Ruby implementation, went ahead and just, first thing we need is cons with car and putter methods on it. So we'll go ahead and add that framework. And then, sitting on top of Ruby plus my new con structure implementation, now we're ready to go. And so that, just adding a little bit of infrastructure, you can make it go. Garbage collection. We could say the same thing. We could say, someone could say, yeah, one might suggest, oh, well, after I get done implementing cons, car, and putter, I'll just build a runtime system. That doesn't seem like the right decision. Once you do that, you're not sitting, what platform are you sitting on anymore? And this reminded us both of Greenspun's 10th law, which is, any sufficiently complicated C or Fortran program contains an ad hoc, informally specified, bug-ridden, slow implementation of half of common Lisp. By the time you're sitting on top the infrastructure it took to get there running, it seems like you've almost implemented the host language you wanted in the first place. There's room to do some infrastructure development, but if you go too far, then you've made a mistake. There have been lots of miniKanren implementations.
Whoa. That's a lot.
That's a lot of them. You'll notice one that we wanted to highlight here. The little MicroKanren that we talked about, 40, 50 lines thereabouts, we implemented in miniKanren. Dan and I got a hankering, and I apologize to you in public, Dan, for suggesting this. Dan was nice enough to go along. So it can be done, sort of. In miniKanren, we don't have real arithmetic like you normally do. It's all done with bitwise binary multiplication. We can thank Oleg Kislyak for that. So anytime you want to use numbers as separating them from lists, otherwise, you got to tag it. And so you have to check for those tags anytime you're doing anything.
It's painful.
We can't rely on miniKanren to provide lexical scope. So we had to write an interpreter. To make the implementation tractable, we limited each program to one single recursive relation, and you had to use tags to dispatch them where you wanted to go the next loop around. It worked, but programs were pretty verbose, and
we have to thank ACL too.
Yes. You can go on miniKanren.org and check it out, and I don't even want to show you what it looks like to do appendo. we still kind of love it, but only a parent could still love it after this. Clearly it's made a mistake. So programs are pretty verbose and it doesn't have great divergence behavior. So sometimes it's just not a hospitable host. So just because you can do it doesn't mean you should. And that's probably the most important takeaway for a host language. That you can get it done. Maybe you should consider a higher bar for that. Other people have given some other bits of advice. Some of it we just got off Twitter. Others we solicited for how to implement your miniKanren. And they said that, so be aware that concells aren't the same as lists. We rely heavily on, in our implementation, using improper lists, lists with maybe what looks like lists until you get to the very last cell and it's got something in there. It doesn't end in an empty list necessarily. So you're going to have to be aware to emulate that or code around it. If you're in a language without macros, those delays we were talking about, you'll have to add those explicitly. We've got examples of how to do that off on miniKanren.org. For the rest of the macros, people noticed, and Dan showed me a technique he pioneered decades ago, I think. Just maybe it's one of those list tricks of the trade.
Somebody asked me a question, I gave them it off the hand.
Right, so you can use list of goals to avoid using the macros. You can use numbers to help you know how many variables you want to freshen. If I'm using closures to build variables, then I don't know the arity off the top of my head, and you have to pass the argument along, but you can get something that's good enough to run. The search, the MicroKanren and miniKanren both come with a complete search. It's sort of tricky to look at, so other people suggested visualizing it, drawing it out on paper, and seeing how it's getting the answers it's getting. That's one way to test it. Other people wanted a bigger test suite. If you're running low on test examples, go to miniKanren.org and grab one of Will's big giant test suites. But there's room for more. And why aren't there more? And this is the part where we implore you to go build your own MicroKanren. I think there ought to be an array-based miniKanren that we were talking about. There ought to be a tree-based one from, I don't know, Rafal or something. The settle language, the set-based language. I think it would be cool to see what it looks like having a miniKanren based on that. I think it'd be cool to have a logKanren. Why can't I have logKanren already? Buttle, you have a logKanren, but I don't think it's in log code, is it?
It's not.
All right, so we need a logKanren. The list we had before, we had about 30 or so. We're a few letters away from having a miniKanren in every language.
In every
letter of the alphabet.
Every letter of the alphabet.
If anyone that wants to get on APL, Bertrand, Idris, K, Oz, TypeScript, Unicode, VBA, Wolfram, and Zero, we'll be getting pretty close here. So, what can we say more broadly about domain-specific languages? It's when you're building your DSL, consider the evaluation. One of the things that we noticed is that we never reuse the streams that we build for our implementation. And since we never reuse them, if we were relying specifically on a call-by-need language, we'd be using a lot of unnecessary memoization. Consider the evaluation model of your host when building. Having similar data structures helps that program transformation. If you don't already have those similar data structures, go ahead. You may have to implement them or consider changing what your language design is, but make sure those mesh up. You want to also limit infrastructure development. There's a happy medium. If you're doing 3 weeks worth of infrastructure development for what's supposed to be a little one-off language, you should reconsider. But on the other hand, I think if your host language can almost already do all the things you want to, then why are you going the effort to building a whole new language for that? If your host language is most of the way there. So what do we say, the sweet spot? We think
it's the sweet spot.
Yeah, just to toss out a number, make it 60-70% of the way there. What you're looking for is when you can add with a limited amount of development effort a whole lot of expressivity with a new language. And so having a small number of lines, elegantly written lines of code, giving you a lot of expressivity, that's a sign that something's gone right. And it reminded me of something Alan Perlis said, and I never feel bad when my thoughts echo those of Alan Perlis. It was that a programming language is low level when the programs require attention to the irrelevant. If I'm having to implement a whole lot of infrastructure to get to writing the language that I wanted to write, you shouldn't get there from here. You need to go somewhere else to start. But there is lots of flexibility in the design. The 50 plus implementations show part of the design space there is, and I think there's room for a lot more. So if you've got the time, how about another Kanren? That's Dan and I. All the rest can be found at miniKanren.org. Thank you all very much.
Is there a type level miniKanren?
A type level miniKanren. I don't believe so. What are you doing this afternoon?
What, ML?
No, a type level miniKanren.
Oh,
Yeah. Once you get it going in Idris, then you'll kind of. Good answer.
So in the previous incarnations of this of miniKanren, you're able to define relations just as normal racket functions.
yes.
So what exactly are you doing now with your define relation macro that's different than just a function?
There were a lot of delays.
Okay.
And now there are one per definition. And of course, if it's recursive, it'll get another one, but there's only one. And furthermore, if you happen to have mutually recursive definitions, then you can still get by with one. So it changes the perception of how complicated things are. Now I'll tell a little story, which is when we were sort of sometime after the book came out, we were starting to think harder and harder about this completeness problem, and we had an approximation. And what we would try to do is, we'll stick a delay here, we'll stick a delay here, and little by little we got closer and closer, but it was an absolute chaotic structure that we were working from. We didn't know what was happening at all. Where with MicroKanren, we now know exactly what's happening. We make a small change to a pen, we make a small change to a pen map, and it's done. And it's not us thinking about it anymore.
There's a reason for each one of those delays now, and it's at a spot that's great to begin doing some static analysis, which I know is close to your heart. So it's a good starting place for doing that sort of stuff. Thank you all very much.
Thanks.
I want to